Hi everyone and welcome into this new video. In this video I want to start a new series, and in this series we will see how to implement a text editor using the C programming language. So this is gonna be a somewhat long series. In this first episode I want to introduce the project and I want to start writing some code. So I hope this project is fun, I hope you get something out of it. The text editor we will build is a Kilo. And we can see it here in action, here. I've already compiled it, so we can just do Kilo. It's gonna ask us for a file name, test.c. And so here we can write a simple hello world, and I'm writing this hello world using the text editor we will build. So this is using Kilo, and we can see like hello world, return 0, we can see we can do that. And then we can pretty much save, we can quit, and then we can like compile the code that we wrote. We can compile the code and we can execute it. So what we wrote was using Kilo, which is the text editor we will build. So I hope this project is gonna be fun, it's gonna be useful, you're gonna learn something out of this. If you're interested in this, subscribe to the channel, show me what you think, like just tell me what you think. And there's also a Patreon for those of you who wish to support me. Thank you very much and enjoy the video. So let's start by discussing the project. Introduction to Kilo. So Kilo is a minimal text editor developed in C by Antirez. And here I put the link to the GitHub page of Kilo and to the blog post that Antirez wrote when he published Kilo. This was done a few years ago. Let me see how many years ago, actually 9 years ago, so a long while. And so that's the basic material. Now the tutorial I'm gonna follow is actually written by Paige Ruten. So based on Kilo, he wrote this step-by-step tutorial, which I think is really useful because it breaks down Kilo into many different steps. So let me just go here. Let me read this. So basically the code written by Antirez now is broken down in many different steps. Here there are pretty much eight chapters, but the last one is just for conclusion. So we have 7 different chapters. We have the setup of the project. We have the first real chapter where you enter into the raw mode of the terminal, and we will discuss this in this video. Then we deal with raw input and output. We implement a text viewer, we implement a text editor, then we implement the search functionality, and finally the syntax highlighting. All in all, we are talking about around 1000 lines of code. And this is why, by the way, it's called Kilo, because it's roughly 1 kilobyte, 1024 bytes. So that's the idea. Now, if you want to just play around with the project, you can just clone the official code and you just do a make. I mean, the project is super minimal, so you can just play around with it. It's very, very fast. And I suggest you, because it's a fun project. You can also read the source code, by the way, the source code directly. As you can see, including license and all, we have 1300 lines of code, where this is the main entry point of the project. Here we check for arguments, we want a file name to edit, we initialize the editor, we select the syntax highlighting, we open the file, we enable raw mode. Here we set the status message for the status bar, and finally we enter into the main loop of the editor, which refreshes the screen and processes a key press. So this is the high level logic, and of course for all these functions there are internals that are, I would say, well layered and structured. For example, the init editor, this one initializes the main data structure, which is this global variable e, which contains like, let me see here, it's basically like this one, editor config. So here is the configuration of the editor, and it contains the most useful aspects of our editor. So we're dealing with this. And then of course we have other structures to deal with the rows of text, with the colors, with the syntax highlighting. You know, like the code is simple, but it's not trivial. And I think it's a great project to get you started in programming in C. I mean, if you want to learn how to program, you need to understand that you need to build meaningful projects. They do not need to be super complex, but they need to be meaningful. And this, I would say, is a first meaningful project that you can do. It does require a little bit of C programming, so if you have no clue about C, you should brush back on the basic syntax, but we will cover, of course, what I can explain during coding. the priority will be to write the code and to explain the code, and I will try to introduce the main ideas behind the various construct and instruction that I use. So this is enough spoken for today, and we can just get on with the code itself. So we can remove the official kilo because we're gonna rebuild it basically by 0 from scratch. So I'm gonna make a directory called text editor, and within this directory I'm gonna make an editor.c, so a file called editor.c, and here I'm gonna make a very simple hello world, like include stdio main void, gonna return 0, I'm gonna say printf hello world, and here I'm gonna do this. Perfect. So we don't have this, we have the text editor. Here I can just compile it and execute it. But of course, we want to create a very simple makefile just to get started with the editor. So the makefile is going to have a target all, it's going to have the editor, and the editor is going to depend on editor.c. Here we have the C compiler, the output editor, the editor.c, then we add all warning, we add the pedantic, and the standard C99, basically. So we are set with this. And then with the clean instead, we're going to do remove editor. So that's a very simple makefile that when we say make or make editor, it's going to build our editor. And when we make clean, when we do make clean, it's going to remove all the file. So we can test it out. If I do make, of course, the editor has already been built, so it's going to execute this, and then I can compile it. If I do make clean, it's going to remove it. So that's good. That's what we need. So that's the first step. Now, for this first video, I want to introduce by enabling the so-called raw mode of the terminal. Now, why do we need the raw mode of the terminal? Well, because the idea is that our text editor will be a terminal-based text editor. It means that this text editor will be executed on the terminal. Like, for example, this is vterm in Emacs, it is a terminal, so I want to execute it within a terminal. Now, when we execute an application within the terminal handles input and output in specific ways, which means that we do not have immediate access to the raw bytes that the user writes in the input, and sometimes the bytes that we write to the output, they are processed by the terminal itself. So the first thing we need to do is we need to tell the terminal, which is going to be our environment, the place where our program will execute. We need to tell the terminal, look, do not do any fancy processing with my input and my output. Just give me the raw bytes. I will take care of everything. Because the idea is that for most applications, the terminal kind of processes input and output in specific ways. We don't want that. We just want the raw bytes. So that's really the first thing we need to do. So we're going to define a function. It's going to be called enable raw mode. And this function is going to disable all the intermediate processing that the terminal does. And it's going to be a void function, enable raw mode. It's not going to return anything, and it's not going to take anything in input. So that's the idea. So how can we configure the terminal? How can we talk to the terminal? Well, for doing this, we need to import some libraries taken from the C standard libraries. And basically, we need the termios.h. Now, this library contains a bunch of data structures that handle the terminal. And in particular, we need this struct termios. And we're going to call this orig termios, like original configuration. So this is the configuration of the terminal when we start executing, and we're going to modify that. So the first thing that we need to do is we need to save original configuration into save original configuration. Now, where do we need to save this? Into orig termios, of course. So the way we do it is with the function tc-get-attr, and we're going to do standard in file no, so we're gonna read it from the standard input. We're gonna save it into orig termios, and this function, if we check into man, like we do man and we do this, as we can see here, this one, it get and set terminal attributes, and specifically this one gets the parameters associated with the object referred by ft and stores them in the termios structure. So we use a file descriptor. This file descriptor is for the standard input. So we are reading the terminal configuration for the standard input, basically. So that's the basic idea. And of course, we can get the terminal settings and we can set the terminal settings. So first, we're gonna get the terminal settings. And we do that as follows. Let me see where this thing is found. I can find the main page. I think maybe it's in, maybe we need to include some other libraries, but we will see as we compile. So that's the first thing. So I would say, let's open, so let me just split the window. I'm gonna remove my webcam so that I can just do this, or yes, let's just do this. I'm gonna do make. So it's gonna say undeclare scdin file no, maybe because it's in a different library. Scdin, let's see, scdlib maybe. No, it's not stdlib. So where is it? Scdin file no. This thing is found in maybe it's in unist.d. Yes, okay. So this descriptor which identifies the standard input is found in a unist standard library. So unist.h. Actually, let me just open the configuration of the compilation of Emacs here. And then it says you have implicit declaration because it's not enabled raw mode, but it's enable raw mode. So here there is a small typo. And so we have our compilation and we can just execute it, and of course nothing is gonna change. So here I'm gonna have my text editor on the left, on top right I have the compilation buffer in Emacs, and on the bottom right I have the shell itself where I can try out different stuff as we program basically. So we have this global variable which contains the original configuration. We save the original configuration and then we are gonna basically change it. So before change it, we want to create a new variable in the local area of this function. And now we're gonna deal with, so modify terminal configuration. So we're gonna modify the terminal configuration. After we have modified the terminal configuration, we want to set new terminal configuration. So we want to set the new terminal configuration. Set new configuration. Okay. So I don't know why it's in red here, whatever. So how do we do that? We do with tc set attr. So we go to scdin file no, and this time it's the pointer to row. It's the pointer to row. Notice that here I'm using pointers because these functions take pointers to the struct terminus. Now in this series we will not discuss, the C syntax. So I assume you know what is a pointer, you know the function. I assume you want to see some real project in C, the way that you can basically understand how to work with the language. Now, however, in the tcset attribute, we can actually specify a third argument here, which is called tca flash. And this tca flash is used to handle the switch between the old configuration and the new configuration. If you go into the main page here, like for example here, and we check for tca flash, it says here, you can read down below, the change occurs after all output written to the object referred by fd has been transmitted and all input that has been received but not read will be discarded before the change is made. So this attribute specifies how the change between the old configuration and the new configuration happens. So this is like a thing, and we set a new configuration. Now, how do we modify this terminal? So to modify the terminal, we're going to use different flags. So basically, we're going to have this row, this terminus struct has different flags. For example, it has a CI flag. Then we have CO flag, and then we have CL flag, and then we have CC flag. So we have different flags. Now, all of these flags will be, like here we will use bit mask operators to change the configuration of the terminal. Now, in this case, we're gonna use the following. We're gonna say break int, we're gonna say icrnl, enpck, istrip, and exon. I'm gonna explain all of this, by the way, so don't worry about this. So what's going on here in terms of C code is that we are removing all these bits from this particular field. From the CI flag through the bit mask operators, we're gonna remove all these configurations. Now, what do they do? So let's start with the first one, break int. So this one, disabling the break int, means that when I'm interacting with the terminal and I press Ctrl C, I don't want to send the SIGINT signal. So I don't want to send this particular signal when I press Ctrl C. And this is why we want to remove this, because we want raw processing. We don't want anything that is interpreted, anything special that happens. We just want the raw bytes. If I press Ctrl C, I want to see Ctrl C. So that's why we do that. Then we have ICRNL, and this basically is the removing, translating input carriage returns into new lines. So by default, the terminal will translate input carriage returns into new lines. We want to remove that. If I press a carriage return as input, I want to see that as the text editor. So that's the idea. Then we have disable parity checking. We don't care about that. Then we want to disable the fact that the 8-bit is stripped for each input byte. Most of these things are disabled by default, but we just want to make sure that they are actually disabled. So we want to remove this stripping of the 8-bit, because otherwise it would just remove us information. And finally, I want to the IXON, this one, IXON, is also another processing where if you press Ctrl S, it's gonna stop the data flow, and I don't want that to happen. So do not stop data with Ctrl S, Ctrl Q. So these might seem like confusing things. They're probably the most boring part of the project itself. However, since we are developing on top of a terminal, since our environment is a terminal, we need to configure in a way that doesn't bother us. As a text editor, we just want to read and write raw bytes. We don't care about this extra processing done by the terminal. So that's the idea. Now, in the O flag, it's going to be simple because here we're just going to have a simple not O post. And this is gonna, so let's do this. And this is gonna turn off, so O post is gonna turn off output processing. So remember this one was input processing because it transformed input carriage returns into new lines. This one instead is output processing, and it removes the fact that if I press a control a /n, like for example a new line, the terminal default processing would translate it into a carriage return new line. And I don't want that. I just want a new line. So this is something really useful to put. Then here on the C flag, I have not, and here I put CS8. So basically like this. And this is gonna set the character size 8 bits per byte. Actually, this is not equal, but it is or equal. So here we have to set the bit mask on. Here we are disabling these things with the not. This is the not operator in C, and we are disabling it, right? But in this case, we want to add this byte to this C flag bit mask. And so we do with the or equal. Finally, we have the C flag. So this one contains all the stuff that we want to disable, basically. And so here we have the echo, the iCanon, the EX10, and the eSIG. Once again, I'm going to explain everything, so do not worry. So the echo is to disable echoing. So what does it mean, disable echoing? Is that when we write a character in the terminal, this is like automatically printed on the screen. We don't want that because we want to process the character, and then if we choose, we want to print it ourselves. So we want to disable this automatic processing. Then the iCanon is canonical mode, which means that this would read line by line with canonical mode. We want to disable canonical mode, which means that we want to read byte by byte instead of line by line. So that's also another important thing that we need to do. Then we have this EX10, this one, and basically this one, so EX10 like this, and it says do not wait after pressing Ctrl V. So there's no waiting time. I just press Ctrl V. Like anything that is handled by this kind of special characters, we don't want that. We just want to see the raw characters. If I press Ctrl V, I just want to see Ctrl V. That's it. And finally, the last one is gonna be iSig, which is gonna turn off signals. So like the signals, if I press certain characters, this is not gonna send signal to the process. If I want signal to the process, I will handle it myself. So this is the main configuration that we have to do. And finally, there are actually two more things. Row C_cc, vmin equal 0. and this is gonna be the minimum number of bytes of input needed before read can return. So we want to write 0 so that even if we read just a single byte, we're gonna return. So we want to read byte by byte. That's the idea. And then I have another field in CC, is called vtime, and this is gonna be 1. And instead, this is the maximum amount of time that read has to wait before returning. And this is defined in tenths of a second, so putting 1 means 100 milliseconds, basically. So this is the amount of time we're gonna wait before the read can return. So that's the idea. Now, this is almost done. However, we need some error handling when we save the original configuration and when we set the original configuration. So we want to create a function, which is going to be called function die, which is going to handle errors. It's going to take a constant string, and it's just going to do p-error of the string, and it's going to do exit of 1. So that's the idea. Of course, we need erno as an header here, erno.h. And basically, when we do this tc get a ttr and set a ttr, we check if there is an error. Now, how do we know if there is an error? Well, the idea is that these functions will return a -1 if there is an error. So we say, if this one is -1, then I want to die with the function name tc get a ttr. So basically, tc get a ttr here. I can say row mode tc get a ttr, and I can do the same thing for the set. So if tears returns -1, I'm gonna say die, I'm gonna say row mode, and I'm gonna say tc set a ttr. So that's the idea. So let's try to compile this, by the way. Let's try to compile this. I'm gonna say yes. Here we have a bunch of errors. Now exit is found in stdlib. So let's include stdlib. Let's recompile again. Here I have it's brk int undeclare, probably because I type it wrong. brk int, brk not bkr, brk int, break int, perfect. And now it properly compiles. So essentially we are able to set row mode. So here we set row mode, and then we return at 0. Now, before exiting to, what's the idea? The idea is that we want to have a function that will disable row mode after we have finished processing our program. After our program ends, we want to disable row mode because we want to restore the previous configuration. For example, if I just execute now the editor here, and of course it's not going to do anything, but basically now if I try to type again after the program is finished, I'm not going to see any character that I type. Why this happens is because once the program is executed, it has changed the terminal configuration, and the terminal configuration was never restored. So this is a problem. The basic idea is that I want to execute my program, but when the program stops executing, I want to disable row mode so that I can continue with the normal execution. Which means that I'm going to have another method, another function called disable row mode, and this disable row mode, what it's going to do, it's simply gonna restore the original configuration. So remember, initially, during the startup of the program, we have saved the original configuration in this struct original terminus, and so now we need to restore it. So we need to restore here, restore original configuration. We do a set ttr, we do an orig terminus here, and disable row mode. So disable row mode, here I have to say enable row mode, say enable row mode. And basically we are good now, because now I'm gonna compile it, I'm gonna execute it, and after I'm done, the terminal is as good as before. I do not see anything weird because all the terminal configuration that was present before executing our binary is restored after the binary has finished its execution. Now, as a last thing, of course, a text editor needs to read bytes and needs to write bytes. So let's write a little function here, not really a function, just a bunch of instructions that will implement a very simple loop where we read a byte and we print it out to understand if you're able to read the bytes. So this is going to be an infinite loop, like we're not going to finish it basically. We're going to say char c equal the empty, like the zero byte. And then we're going to say if I'm going to use the read function to read from the standard input. I'm gonna put the character read into C. I'm gonna read 1 byte. So here I have if read is -1 or Erno is different than E again, I'm gonna die basically. I'm gonna die because I have some errors. Otherwise, at this point, I've read the character. So at this point, I've read something, I can print it. Now, the way that I print it depends if it is a control character or it isn't. So how do I do that? Well, I can say if is CNTRL, if it's a control character, I'm gonna print it as as a number, basically. See? Otherwise, so let me do this. Otherwise, I'm gonna print it both in the numerical value, but also in the character value, because this time is can be read as a character and as a value. If the character read is Q, I'm gonna break to exit the program. So if I press Q, I'm gonna break. So let's do this. It's gonna say this is implicit function is CNTRL. Let's see if where this is found. This is found in ctype.h. So let's include this ctype.h here. Ctype.h. Now it works, and now here I keep printing 0 because it doesn't really it's not blocking read. But if I press something like A, it's gonna say A. If I press something like B, it's gonna say B. If I do control something, it's gonna just print out the number like 3 or like 17 for control Q. Control W is 23. You see, like I just read every character. I just read it like this. If I press Q, it's gonna exit. So this is a good starting base for our text editor. What we did in this video is we have configured the terminal. We have removed all extra processing that we don't really care, that we don't really need. We have set the terminal so that each byte that is typed by the user is going to be read directly by our process, and the terminal will not do any processing to it. And each byte that our process writes to the terminal is going to be written exactly as it is to the terminal. The terminal will not process it any further. So basically, all this configuration comes down to disabling any input processing, so processing on the input, disabling any output processing, so processing on the output, disabling signals, disabling the special behavior of control characters, like when we press some control character and the terminal does something different. We don't want that. If a user press any keys, it could be a control key, it could be any key of the keyboard, we just want to see that raw byte. And we also set the character size of each byte is going to be 8 bits. And we set you can read as much as 1 byte in every 100 milliseconds, basically. So that's the configuration we did. In the next episode, of course, we're gonna expand more on this. We're gonna write functions to read and handle raw bytes in input and output. We're gonna write functions to visualize the data of a file, to write, to edit the data of a file, to do searching, syntax adding, and things of the sort. So I hope this series will be interesting because it allows you to build step by step a functional text editor. So that's it for this first video. Let me know what you think about it, please. If I should continue the series or do something else, just let me know, and to the next video.